purpose of the group is to share knowledge across the profession. We try to meet up on a quarterly frequency. And we do have also the Wellington Bridge Group and the Christchurch Bridge Group as well that are active, and they try to have a similar frequency of meetings. So the aim is to have a regular set of meetings that are talking about bridge things right through the year. And of course, those meetings can be attended online as well as in person. So the presentations typically focus on one or more of the following: significant current or recently completed bridge projects. That'll be the subject of the presentation tonight. Any advances in bridge construction practice, any advances in bridge design practice and technical developments, and any bridge-related research topics as well. So any of that, we are keen to hear from people that have got subject matter for presentations. And just to mention that we are funded by SESOC, the Structural Engineering Society, so they fund the catering at our meetings. Otherwise, it's a voluntary group for committee members, etc. So that's the names there, the members of the steering committee for the Auckland Bridge Group. So if anybody does have subjects or presentations that they're keen to give in this forum, then please get in touch with one of the members of the committee there. So this evening we'll be talking about the Northern Corridor Improvements Project, and I'm delighted to have with me this evening two people from Head Construction that took part in the construction of the project. Adam Blackie, who was the construction manager for the project, and Jonathan Holdaway, who was project manager as well. So delighted that Adam and Jonathan could join us this evening to give that construction perspective on the project.
I was just the bridges manager at NCO. I'm just different.
Oh, sorry,
yeah,
sorry. Bridges manager.
Both, yeah.
I think you're a project manager now, though, Jonathan. Okay. Right. Okay. So with no further ado, we will start with our presentation on Northern Corridor Improvements Project. So just the structure of the presentation, we'll have about 10 minutes from Adam, who'll give a little bit of detail about the project purpose overall and the scope of the project. I'll talk a little bit about the design aspects of the bridges, and then Jonathan will go into some of the construction challenges that we had on the project. And then, as I say, we'll have some time at the end for some questions if there are. Okay, with that, I'll hand over to you, Adam.
Good evening, team. Good to see you all. Thanks for having us along here. Probably just starting off, just a bit about myself. I think Paul said I was the construction manager at NCI. I was there for 6 years myself. Started off as a zone manager at the start of the project and had 2 years in that role, 2 years in the structures manager role, and then 2 years as the construction manager at the end of it. So it's a project I know pretty well, and had a good time there, and yeah, happy to share that with you guys today. So I guess Jonathan and Paul both talk about the design and construction of the bridges. I'll just give sort of more of an overview of the project and I guess the purpose behind it and sort of what we're trying to achieve there. So just for those that don't know, if you live in Auckland, it was, I guess, first of all, just look at the bigger picture, and on a national scale, 55% of freight comes through Tauranga, Hamilton, Auckland and Northland, quite a key transport activity area, along with about 50% of the national GDP as well. So excuse me, strategically from a transport area, it's quite important. You move sort of over to the Auckland side of things. You might have just studied in university, but obviously the Western Ring Route was one I learned about when I was at university many years ago. And I came out and I've worked on a few sections of it now, but they've been busy building this section around the city for the last 20, 30 years. It's been a whole lot of projects all combined, and I guess the Northern Corridor improvements on the northern end there, that was basically the final link to get that diversion around the city and linked up with the north. So just before I go into a little bit more about the project, just from a procurement point of view, from NZTA, this is a graph that they use for procuring their projects. You've got your traditional lump sums and measure and values cost plus projects down here for probably your standard, the design and construct, getting for the bigger projects and that. But as you get sort of bigger in terms of scale and complexity and risk up here, the client's also looking for the innovation, flexibility, and a bit more client involvement. And there's program constraints and things just get really complex. They sort of tend to move up into this category up here. So NZTA have had done a lot of they call them now pure alliances. I did some competitive alliances there for a while, but I did find that the competitive alliances just became a bit of a glorified sort of design and construct. It was still sort of driving the price down, but they weren't sort of getting the value of it. So they brought in what they called a hybrid alliance, which kind of sort of fits in the middle of those two. And when they're procuring it, the idea of that was they give the contractor and the designer the threshold price that they've got to spend on the job, and then it's up to the designer and constructor to come up with innovative ideas that how much value they can put into that by using that money, what they can offer them, and that's kind of what the projects are awarded on. And so I guess as a client, they're just looking for the best value for money that they can get from that. With NCI, that was kind of going back right at the start. I think it was awarded in the initial award of the IPAA phase was sort of mid 2017. The actual PAA, which is the Project Alliance Agreement, was awarded in December 2017. But you can see there when that was going on with that procurement of the construction and the design side of it, they were also acquiring properties. They didn't have all the properties to start to build the project when we were actually getting going with design and starting some of the construction on site. And then the planning approvals, those all weren't in place at the time either. So with going with this hybrid alliance type model, they were able to have that flexibility, have the collaboration from the contractor and the designer, and I guess as a team solve a lot of those problems and be flexible to get going. In December 2017, we were awarded the contract for 447. A lot of additional scope was added on. That was probably because of some of this flexibility and a lot of uncertainty with things. There was still additional scope to come, and that sort of pushed it out over 700 million. For the core scope, we have State Highway 18 to State Highway 1 connection. So that was the underpass. That was probably one of the key links. There was the extension of the Northern Busway. And there was all the shared user paths and that went along just with the local connections and that we created along the way, as well as, with all of that, there was kind of motorway widenings and improved surface rides, but that was kind of your main core scope. And then you probably think, well, geez, from 447 to 700 million, that's a lot of extra scope. What sort of entailed that? So the additional scope, so we had the Turahanga Whānui Bridge. That was one of the early packages of work that we got added on at the start, and we built that fairly early on because Watercare had to get a water main across the motorway. So that was a bit of a combination of sort of NZTA and Watercare combining as clients to come up with a cycle and walking bridge and a pipe going through the middle. So quite a nice photo there at night. We had as part of our project, we had to move the hockey ground that was there. And to do that, we had to move the pony and BMX clubs to new places. So that meant going and building new facilities for all of them. And that was kind of, you got the pony, the BMX, the hockey, and then obviously added in there a photo of the Constellation station, which was added on the upgrade we did there for receiving all the buses and that coming up the busway. We had the Rosedale bus station enabling work. So that was this, when we tendered the project, it was, I think we just had mainly just a big retaining wall through there with a little bridge across Rosedale Road, but post-award, AT were pretty keen to set that up for future bus stations. So you can see there the idea was that the bus station gets built on that bridge. So we did all the enabling works for that. We had the Rosedale replacement bridge. So originally at tender, that was we're just widening the existing bridge, but as part of the extra scope, they asked us to demolish that bridge and build a whole new one. We had a complete overlay of State 001, so 2 heavy-duty layers of asphalt over the existing pavement. It was quite a big chunk of work. The Alexander underpass. So originally we were just extending that, but we did a whole complete replacement. So a bit of staging, we were able to build that in 3 stages across State 018. And then there's the water care wastewater works. As part of our project, there's a whole lot of wastewater lines that needed to be relocated and upgraded and that. So we sort of picked up all that work too. So probably this is just the last one that'll, I guess, lead into what Paul and Jonathan have got to say, but probably one thing that stands out for me was just the initial planning when we, before we started the project, even through the tender phase, and that sort of developed into our sort of early construction design phase as well. Just the, I guess, the strategy we had for managing the traffic on the project. There was a real big driver to look after all the customers, particularly after some of the work on the other Western Ring route down the Northwestern, where, while we're building that, they'd close off the bus lane. So buses were struggling to get to town. You'd come down and they'd move lanes slightly and you'd have ghosting or shadows of the old lines, and that people be all over the place in the sunlight and rain, and that was often difficult to see. So just from a customer experience, it was pretty crap. So I guess there was a real push at the start. How can we do this better? So before we got busy designing and constructing, basically just had a simple methodology. Okay, well, maybe if we move traffic around less and we do it in whole lane widths rather than just moving it to suit construction, we actually just keep them in a lane. So when they're approaching the project, they get into a lane and then they just stay in that lane for the whole project, and then they just pop out the other end back into the existing. So it was a pretty simple strategy, but we sort of stuck to that for 6 years that we built it, and that's kind of was a big thing that made the project a success. So that was kind of the basic staging. It probably ended up a few more than that, but it was, when you look at it, that was the existing. The first stage was basically just take out the median barrier and put a temporary barrier in, slightly squeeze up the lanes, but not much, and then put another barrier in. So stage 1 was effectively building the northern, this green bit was building the northern side of the project. So do that, move all the traffic over onto that northern side to give us room on the southbound side, build all the southbound side. Once we've done that, split the traffic and then do the piece up the middle. And that was, I'd say, some pretty long stages there, 14 months, 13 months, 8 months with COVID and various other things that extended out a little bit beyond that. But that was kind of the basic fundamentals. And by doing that, as I say, we improved the customer journeys through the site. The buses, they were quite key just by the sheer number of buses that came through with lots of people on them. So one of our mottos was "Don't muck with the bus." The bus was one of the key things to get through the site. And with all the we got a lot of statistics from the Auckland Transport Centre and that with how we actually how we performed with that. And once we got everything set up and we had buses running through, we actually improved some of the bus journey travel times through there. And same with the throughput, because vehicles were able to do 100 k's through the site, and it was all aligned quite well. We actually had a lot of success with that. So that kind of set the standard. So a lot of the projects on the motorways you see out there now, they're trying to do something similar where they're keeping people in nice tidy lanes, keeping them straight, and doing things in whole bits of work. So I think that's about all I had just from a quick overview. Probably being structures, you'll be more interested in the bridges and things, but it gives a bit of an overview. I'll hand over to Paul now, and he can go through a bit more about the design of the bridges. Thanks.
Great, thanks very much for that, Adam. Yeah, so that gives an overview of the project and what some of the drivers were in terms of what we were looking at for design and what we're looking at for the construction phasing. So thanks for that, Adam. So I'll speak a little bit about the design aspects of some of the bridges. So I'll give a bit of an overview for the structures on the project. Say a little bit about the structural form that we used. Say a little bit about the busway bridges, particular structures for the busway extension. A little bit about the modification and replacement of the existing bridges on the motorway section. And then a little bit of a focus on the State Highway 1-18 underpass structure, which you saw on one of the slides that Adam put up there, which was one of the focus of the project. But very interesting structure. I'll say a little bit about the design of that and some of the piling construction stage aspects on that. So this is an overview of the bridges on the project. So if we look at the graphic on the right, so you've got State Highway 1 going top to bottom there. You've got State Highway 18 coming in at the bottom left of that right hand diagram. So one of the key things of the project was to create those motorway to motorway connections between the main north-south State Highway 1 and the State Highway 18 going out to the west. Looking at so the bridges are in the red bits on that graphic. So going from top to bottom, so we had a couple of overbridges there, the Albany Busway Bridge at the top, which takes the busway into the Albany Park and Ride, and McClymont's Road Bridge, which was like a replacement of an existing bridge. Coming further down at the Greville interchange, there's an existing bridge on State Highway 1, which we had to widen. And just to the east of that, we had to provide a new busway bridge, the Greville Busway Bridge there. Coming a bit further down, we've got the sort of big red patch there is the Rosedale Road Bridge replacement. So there was an existing Rosedale Road Bridge there, which we had to fully take out and put a replacement structure in that. And again, just to the east of that, just to the right of that is the Rosedale Busway Bridge, which had the sort of big station on it. At the bottom there is the Constellation interchange. So again, you can just see right at the bottom there, the bottom red one is the widening of the existing Constellation Bridge. And again, just to the right of it, just to the east of it, is the new Constellation Busway Bridge, taking that busway extension. As you come through off to the sort of bottom left there, there's another couple of big viaducts there, the Caribbean Drive eastbound and westbound viaducts, which took that State Highway 18 link over a bit of soft low ground. And then right at the sort of western southwestern corner of the project was the Alexandra Stream underpass. So there's quite a lot of bridges and structures that had to be done on the project, and all around obviously the motorway traffic situation. So in terms of structural forms, this is the typical structural form. So good old Super T beams and a slab deck. This example is one of the Caribbean Drive viaducts down at the southwest side of the structure there. A lot of use of fully integral connections between the piers and the deck, as we can see there. Two-stage connections. So you can see the Super Ts at the top of the cross section there. We had the sort of stage one of the headstock, which the beams could land on, and then the infill portion above that in the deck portion there to make the fully integral connection. Another aspect you can see at the bottom there, at the bottom of the pier, in quite a few locations, we adopted an oversized steel casing around certain piers to, particularly where the piers were short compared to other piers on the structure. so that we've got a bit better balance of stiffness on the longer viaduct structures. And that's just showing a cross section typical cross section through one of the intercal connections. So again, at the bottom there, we've got the stage one of the headstock. We've got super T beams coming in at the left and right, which get landed on the edge of that stage one, and then above that we've got the stage two of the headstock, which is the infill bit, which creates the intercal connection. And we've got there's a typo there, sorry, extending V-tensioning strand from the super T beams through into that integral connection to account for any secondary moment effects from the integral deck. And in terms of barriers, typical TL5 edge barrier detail you can see on the right there. There's a lot of attention given to the urban design patterns on barriers, and we had themed zones on the project with iwi input into the designs of those barrier features. And that's just a picture of one of the super Ts going on one of the bridges in a night closure. That's the Albany Busway Bridge right at the northern end of the project. Interesting structure, the Rosedale Busway Bridge. That's an artist's impression of what it looks like, or what it will look like if and when they do the bus station. That's looking west along Rosedale Road. So we've got the Bridge 5 Rosedale Busway Bridge in the foreground. And you can sort of just see just beyond it is the sort of replacement Rosedale bridge taking State Highway 1. So north is off to the right, south to the left. That Rosedale Busway Bridge is very interesting because we had to have provision for the bus station. Like at one point we were going to do the bus station as part of the project, but now it's a provision for a future bus station. Which is partly accommodated on the structure itself. So you can see the sort of platforms and the canopies for the station there in the artist's impression. So it's a very complicated structure both for the design and for the construction team as well on site. As it turned out, the decision was made not to proceed with the bus station at this stage. So we then had to think about how to leave the structure in an operational mode without having built the station itself. That's a plan view of the southern end of the structure. It's affectionately known as the aircraft carrier. So there's 5 spans off to the left of that, to the north of it. This is the southern end. At this southern end, it sort of splits into 2 structures. So the bit at the top there is taking shared use path through, and there's a connection into that future station on the shared use path. And then the bit at the bottom is taking the busway northbound and southbound. The yellow parts of that are the platforms, and the orange parts are the lift and stair tower of the future bus station. So they're not actually built at the moment. That's just another artist's impression of a view of the bridge and the station area. That's looking southwest to the southern end of the bridge, showing the provisions that we have for access and egress to the future Rosedale station. And you can see some of the urban design inputs into that area, such as the coloured panelling along the edge of the shared use path there, and some of the patterning on the abutment panels in the distance. And with the busway bridges, they are future-proofed for provision of the light rail at some point in the future. So that's just showing what the arrangement would be. The shared use path would be kept, and then on the right, the main part on the right, which is taking the busway at the moment, that will potentially ultimately take light rail. So modification replacement of some of the existing bridges. So I mentioned that we had widening to do at Gravel Road at the Gravel intersection. and widening the existing bridge at the Constellation Drive intersection. And I think that Jonathan's got a couple of photographs of that Constellation Drive widening in his section. But then at Bridge 6, the Rosedale Road area, it was originally way back contemplated as just a widening, but then became a replacement. And that was partly due to the fact that they wanted a wider road underneath the structure. So we had to lengthen the span of the structure, which meant a full replacement rather than widening. So that was the original sort of cross section through the original Rosedale Road Bridge. So that bridge itself was done in several stages. So there's the part in the middle, the original 1983 bridge that you can see in the middle there. And then off to the right, it was widened in 1989. And then it was widened on both sides in 1999. And then widened again on that left-hand side in 2015. So quite a sort of mishmash, complicated structure that we had to deal with. You can see the sort of indication of transverse post-tensioning on some of the later stages of the widening, which we had to contend with in terms of the demolition and replacement of the structure. That's just showing a sort of typical construction stage. So we were having to do this in transverse stages. We were having to take out parts of the existing bridge and put in new parts in transverse stages. And those transverse stages were to tie in with the traffic management staging that Adam alluded to. So the whole thing was done in I think it was 6 stages, wasn't it? The Rosedale replacement. So this is just a typical section there. So you've got part of the existing structure still there in the middle, taking the southbound lanes. Over on the left-hand side, you've got part of the new structure taking northbound lanes, and then you've got over on the right-hand side some construction underway on another stage. So so we're jumping around quite a bit on that bridge. So quite complicated construction. And because we were actually lengthening the bridge because they needed a wider road underneath, it meant that the construction depth of so it remained a single span structure, so the construction depth of the structure increased. And to thinking about headroom, that meant that we had to think about lowering the road underneath. And Jonathan will say a bit about that in his section. Even for the new structures, we had to think about future proofing for widening of them. So this is a plan view of the one of the Caribbean Drive viaducts, the one that takes the link to the west. So that's it's about a 250 metre long 8-span structure. So we had to contemplate the potential provision of an additional link in that area at some point in the future. So basically this Bridge 12 Caribbean Drive westbound takes the link that comes from the State Highway 1 from the north going off to the State Highway 18 to the west. It comes under the underpass structure that we mentioned and then onto this viaduct. So basically the project is giving links from State Highway 18 to the sort of north facing links, if you like, on State Highway 1. There's no links to the south face of State Highway 1. But part of what we had to contemplate was putting in a link that took State Highway 1 northbound through to the State Highway 18 westbound. So we had to do some future proofing for that link that sort of comes around the corner. So we had to contemplate widening of Bridge 12 to allow for that. So we had a scheme in mind for that and looked at what we needed to provide for potential future widening of that. So we did put some additional embedded reinforcement in the edges of the headstocks to allow for future widening. And we had a design scheme that was based upon. We've got the sort of flat soffitted headstocks on those Caribbean Drive viaducts, which I don't think they look too great, but it's to facilitate potential future widening, so that you can just come across on the same level. The section on the right there just indicates, I don't know if you can see it, but the additional reinforcement that we had to embed in the headstock to allow for coming in at some point in the future, nibbling away and connecting onto the existing headstock to provide the new widening as an integral structure. Okay, so talking about State Highway 1 to 18 underpass. So say this very interesting structure. So this it's a top-down construction. Putting in contiguous board pile walls on either side of the underpass, and then casting an integral in situ reinforced concrete slab at ground level. And again, like the Rosedale Bridge, we were having to do that in transverse phases. I think it was five main phases for the underpass. So it's accommodating the link that I mentioned, the one that could, if you're coming south on State Highway 1 and wanting to come over to the west, that's the link that it's providing. Originally in the reference design, this was a viaduct that was going over the top of the existing State Highway 1. But when we were doing our tender design, we looked at the option of doing the top down and putting it underneath, and that's what we went with, and successful with that. So yeah, so this had to be built beneath the live State Highway 1 motorway. Let's say built in transverse stages, and because it's built in stages to match the traffic management, we also had to think about, in terms of the construction joints between stages, they had to align with the traffic lanes. So that meant that construction joints were at quite a skew angle compared to the actual short span of the structure. So we had to contemplate that, and so the whole thing was built. Say the slab's built at ground level. When the whole of the structure is built, then the structure is excavated underneath to form the link going underneath. So that's typical cross section of the underpass. So some facts and figures of it's about 110 meters, 115 meters between portals on that structure. There's retained approaches on either side of it, about 120 meters long as well. There's a minimum vertical clearance for vehicles of 6.25 meters. That's from the highest point of the carriageway up to the soffit of the light fixings. You can just see there on the cross section. It's on a horizontal radius of about 245 meter radius. We've got a skew relative to State Highway 1, varying from 26 degrees to 40 degrees. So quite a complicated geometry to deal with. So in terms of the piled wall, so contiguous piled wall, you can see on the left hand side there, you've got the pile on the left, and then a bit of an air gap, and then precast paneling in front of the piled walls at the end. So there's a lot of consideration on because we were constrained in terms of the road geometry, and obviously wanted to minimise the span of the underpass structure. A lot of consideration as to the tolerances in terms of the position of the piles and the verticality of the piles, and how that related to the dimension of the paneling compared to the piles. So, and I'll come on to that in a little bit. Also, 120 meter long, 120 meter long structure. You have to think about a situation where there's a vehicle fire underneath it. So the structure is fireproof for a 2-hour fire, or a modified hydrocarbon fire. The paneling in front of the piles, that's the fire protection for the piles. So they had to, give the required fire resistance for that 2-hour fire duration. And there was the addition of polypropylene fibres into the concrete mix of the panels to guard against explosives falling of the panels in a fire situation. For the roof slab, there was a spray applied passive fire protection layer on the soffit of the roof slab. There's the detail on the right hand side. It's actually shown vertically, but if you can imagine that around 90 degrees horizontally. So that was the fire protection, which had a stainless steel mesh that was connected into the soffit of the roof slab, stainless steel anchors, and then the I think monocoat, was it monocoat fire protection coating was sprayed onto the mesh, and that was rated to, I think we had to limit the temperature at the concrete face to, I think it's 350 degrees C. Just thinking again about the tolerance on piles, we had about 300 odd piles on the structure, 750 mil diameter at 780 mil centres. So quite a tight working tolerance on that. We needed to sort of think about allowances for rogue piles that went off alignment. That was determined by that say constrained by the available width. But over 300 piles, we had a handful, like in the photograph, that actually went off in terms of the verticality and positioning. So we had to come up with options for dealing with those that were beyond the tolerances that we'd already allowed for in terms of the dimensioning between the piles and the precast panels. I think there was only maybe 2 or 3 piles where we had to do something specific in terms of modifying what we already had for the structure. So this detail here just shows how we handled that small number of the piles that had gone too far out of tolerance. So you can see on the left-hand side there, we've got a pile that has come too far over towards the panel, such that it's clashing with the bottom of the precast panel, which is normally has its footing down by the barrier level there. What we actually did was cast a small in situ corbel over part height of the where the panel should have been, and then had above it. So that's the green part there, and above it had a smaller precast panel that sat on that corbel. So that's the clashing pile on the left hand side, and for the width of the panel, we had to carry that corbel on to over that width. So you might have had a pile next to it which wasn't out of tolerance, but you still had to have that corbel detail for it. And so we had to think about seismic restraint of those smaller panels, and also the fire protection for them as well. That's just a detail of the corbel reinforcement. So we've got the panel at the top right there, and then we've got the in situ corbel with reinforcement that had to be drilled back into the piles for that in situ corbel portion there. Hold down bolts provided for those shorter panels between the short panel at the top right there and the corbel down below it. Taking seismic loading and horizontal fixings at the bottom of the panel as well, that again drilled back into the pile itself. And we had to take the monocoat. So the corbel itself was protected with the same monocoat fire protection layer as the soffit of the roof slab, and we had to take that monocoat layer up above the corbel and up into beyond the horizontal fixing at the bottom of the panel there, and we gave some consideration to the bending of the precast panel in the fire situation, so it actually bows out into the underpass in a fire situation. So that no fur, no sealant there was added at the top of the monocoat, so that it would allow for a little bit of deflection of the panel in that fire situation. So all quite interesting stuff to have to think about. And of course, that was happening while construction was proceeding. So quite a bit of design support during the construction phase to allow for what was happening then. Just one last detail on that. That's a plan view down on the corbel. The piles are at the bottom there. We've got the corbel cast there. We've got a normal panel on the left-hand side. So again, in terms of making sure we've got the fire resistance to the piles, we have to bring that monocoque protection layer right the way across the corbel, and then think about the normal sealant and Actifoam fire resistance material in the joint between the corbel and the next adjacent normal panel. So quite a lot of detail in this photograph for that. Okay, that's all I wanted to say on the design aspects. Jonathan, I'll hand over to you.
Sure. Evening, Ron. So yeah, Jonathan's my name. Worked with Adam there at NCI. I'm there for 5 years, I think. Yeah, started in the bridges role and then went to the zone role in the last 3 years, bridges manager on the project, looking after the structures. So I'll just got a lot of photos here, not too many texts. It's going to be pretty quick, so we get through on time. So I'm just going to concentrate on 2 structures, actually, the underpass bridge 8 and then Rosedale replacement bridge 6, which Paul's touched on as well. So I'll just, yeah, basically just talk through the, I guess, progress of those structures from start to finish and some challenges along the way. I'll press the right button. Yeah, so as Paul's given us an overview of the underpass, I won't repeat it, actually, he's covered that well. So yeah, it's the link from State Highway 18 through to State Highway 1. So done in many stages, or 5 stages across the road in the top-down construction. And yeah, dictated by our traffic phasing up the top. We had to keep building more slab on the top to gain some real estate to push the traffic over and work our way successively across the motorway. Sorry, here are my notes. But so yeah, some of our stages are big. We managed to get big bite-sized chunks of underpass to build, and then other times very small chunks, just depending on how we could do the traffic phasing and keep, as Adam spoke about, our Ghostbusters philosophy. We promised that, so we couldn't break it. So we had to move in full traffic lanes across. Yeah, I think stage 3 there was very narrow, but that's all we could sort of get access to, and we needed that little bit of real estate. So next switch, then we could grab another chunk as well. So I think all in all, it was a 3-year journey across the road, I think, before we could start the excavation underneath. So a lot of work doing piles and roof slab without too much glamour for 3 years before we got through underneath. So a couple of aerial photos just here of our progress across the motorway, starting on the left-hand side. So we pushed the northbound off-ramp, on land at that stage around us to grab a bit of real estate, build a big chunk of underpass, roof slab. And then yeah, another stage on the outside. That's our smallest stage. No, it's not. Sorry, that's just working in the middle there. It'd be hazy on this screen. So piling, board piles, average about 15 to 20 metres deep. Contiguous piles, as Paul mentioned, so yeah, pretty much continuous. I think there was a 20 or 30 mil gap between by design, which was good. It did cause us a few issues. So this is just piling through a gate to make sure we stayed on our alignment. But with contiguous piling, sometimes with overpour, there was variable ground conditions. So overpour meant that, that pile had a lump of concrete. So when we did the adjacent pile, it was sometimes quite tricky to keep the drill completely vertical. Some of the challenge we had was literally the space. So with board piling, when the operator wants to really push that bucket where he wants to, it's all about where you put the machine, but we were very limited in some of these piles where we could put the machine. There was just one place to set up. So there was no sort of wriggle room or any particular special thing you could do with positioning of the rig. Some of these piles here, the slew of the machine actually went over the barrier, so they had to be done at night. So it was just how tight the real estate was that we had to work with. And as Paul mentioned, yeah, if you go back one slide, I think this is the conflicting pile, but that's sort of the result there. We're just glancing out of tolerance. So I think 400 mil until we hit with the panel underneath. Deck slab, pretty run of the mill. So we put a site concrete down layer that had to be perfectly on grade, and then we put a wax-based debonding agent on there. We cast the site concrete quite thick. I think it was 200 mil, but that was but later on when we come through and break it off. We'll show you some photos later. It just helped it fall down. We didn't want to be too economical, otherwise you're getting up there with chisels afterwards trying to break that site concrete down when you're doing the excavation. A lot of reinforcement. We love nice reinforcement. It's always a good debate through these evolution of these designs with designers and constructors, how many kgs per cube, but it was a reasonably nice structure to build. Concrete pours always have their challenges, so big volume here, 800 mil thick, quite heavily reinforced, so vibrating the concrete, it takes time. So we usually chose to do this at night time with more favourable conditions, less sunlight. It was the temperature, easy to control. Also our concrete supply, we got I think 400 cube in this pour. We're our biggest pour, so just with Auckland traffic, easy to do at night. You own the concrete plant, and you can keep track of where the trucks are. So we did do a lot of night pours. So yeah, over that 3-year period, once we'd completed the deck, then we went into excavation of the underpass. So due to a technicality, we were digging more than 15 metres horizontal, I think is the magic number. It's defined as a mining operation. So I think that came out of the back of Pike River, long story, but anyway, we had to dig the underpass to full mining rigs. So yeah, that's what the ventilation shaft we're just preparing on the right-hand side. All the machines have suppression and fire extinguishers and all that sort of stuff. So we all had to get trained to wear rebreathers, and there was a whole lot of sort of extra stuff we got educated on. But it's legislation, so we couldn't get away from it. So this is the beginning of the excavation. As I said before, we cast the site concrete nice and thick, and it just really helped it come down in big chunks. Other projects we've done it a bit thin, and yeah, literally getting up there with cold chisels, trying to get rid of it. Just a few progress photos of the excavation as we came through. The ventilation ducting extending through as we proceeded with the excavation. The bad pile again. Because we like challenges, I gave ourselves one more. This was a constructor error, but I don't think he's on the call. But yeah, very smart, capable site engineer. But a slight scoreboard error here, just measured 45 the wrong way down the batter. Anyway, instead of going perpendicular with the top of the batter, sort of came around the side. Anyway, misjudged where the excavation was, and we accidentally daylighted it into the median where we were still doing the trying to cast the slab onto the ground, and then the ground all of a sudden appeared. You see the sunroof at the end of the excavation there. So that caused a bit of a piss and a panic just for a couple of weeks. All of this team had to do a few checks here and there. We had to come up with a temporary works design, so we lost the luxury of just casting on the ground. All of a sudden the ground was, there was a bit of a gap there. So yeah, we quickly did a temporary works design. We had the luxury of being able to pour a ground beam far enough away back from the edge of the batter, and then did a hanging soffit system or false work system, and cast it. Yeah, a little bit of the underpass was cast on some formwork. Doing that, yeah, added a few complications. So Paul actually, the guys did an Austroads paper on some of the things we had to overcome, but one of them was vibration. And because we were hanging the false work off the live lane, the numbers were such that we actually needed to take live vehicles off lane 1 or lane 2. We had to close that lane and we had to push them around us. So we had to do what we call a bull run. So we had to go and clear all our gear out, and we pushed the pavers through there, and we made a lane around ourselves. Fair bit of work went into that. Even though we weren't taking lane capacity out, as soon as you start pushing people around it, they forget how to drive, and it creates chaos with traffic. So we did a whole exercise of traffic counts. It was in the tail end of COVID, which was quite good. That was probably our saving grace. It was in the build up to Christmas. Not a great time to play with Auckland traffic, but just coming out of that COVID level 3 lockdown, traffic volumes are sort of favourable enough that we could. We had that bull run in from Saturday night through to early Monday morning. More photos of the underpass as the excavation then continued. So the muck the ground we were excavating out was quite wet and saturated, which had some challenges until we could push right through and then get it stabilised and get our subsoils in and just give that groundwater somewhere to go. A few progress photos there as we dealt with cleaning the piles up and down and casting the slabs on either side of the piles to take the precast panels. And then placing the precast panels was challenging. So just with the fireproofing design, they had to stop 50 mil from the roof slab. So yeah, no room to really lift up there. It was I think 5 mil tolerance either way on there. That was based on the fireproofing product that was wedged in between the soffit and the panel. So we came up with this lifting design. It's been, other adaptations have been used like this. So it was 80-ton excavator with a few modifications. We took the dipper arm off it and put on a bespoke frame, and then we cast in, there was conduits cast into the panels, or swift lift, sorry, that then we hung some chains on, and we could lift and do all we needed to do with that excavator. So it was a big machine, but it was very useful and did the job. So we could back the panels up to the excavator and just pick them up and spin them around and ease them into position. You can see on the roof there is very, very small tolerance just to squeeze it in there. Massive survey job just to make sure that fit was right. It was yeah, a lot of work. And then it was fireproofing. So once the panels are up, fireproofing. So there was yeah, stuff wedged in between the ceiling and the panels. As Paul said, the panels themselves were fire retardant concrete, so they provided protection to the piles. And then we sprayed a product over the feet and in between the panels. And then a layer of asphalt, and then we pushed the slit form barrier through, which had its challenges as well. Very tight tolerances there. Lucky that was some of our last slit form on the job, so we were able to modify the machine there and slit form right up to the edge of the panels. A few progress photos as we just came through to the end. So that's, yeah, that was the journey for State Highway 1, the underpass. I'm there for time. I'll talk to you now about Rosedale Road replacement, which Paul touched on as well. So that's the one in the circle there. So original scope, as Adam said, was to increase lanes in the State Highway 1 space. And then AT came along and NZTA and a bit of collaboration. Then it was decided that they wanted to widen it underneath as well, which pretty much means a brand new bridge. So that was added in as a variation, and we had to fit it in with our Ghostbusters strategy. Paul had that graphic up before. Rosedale Road and all the different stages it was built. So I guess our deconstruction methodology was just to match the way that it was built. So we just picked it apart in whole sections that it was built. Incidentally, Adam and I worked on the 2015 widening. So 7 years later, we're pulling our own bridge down. So a bit too young to be pulling down bridges that were already built, but that's all right. So Rosedale replacement, yeah, we started with taking off the edge beam, as the ones we just put on in 2015. And then it was yeah, piles and building a section of the new bridge. Just with that real estate game I was talking about before, we had to build, you know, the maximum amount we could, because then we had to go and put traffic on it. So, you know, that container in the background, post and panelled retaining walls there to hold State Highway 1 up. We had to push it as close as we could, just to get the right amount of super T beams in. Then we had to lower Rosedale Road. So Rosedale Road, the original structure is super hollow cores, and we're putting super Ts on, obviously with a greater depth. So, and then with the future proofing for double decker buses and all that stuff, we had to lower it by 1.5 metres. So in order to do that, the footpaths, it was decided that we'd dig out and fill up with flowable fill concrete just to give it a bit, you know, a bit of underpinning or buttress fill, or help that global stability, I suppose. So had to dig out through all the services and fill up with flowable fill, and yeah, the challenges there is just trying to divert all the services in time, and we got most of them done. There was a couple of late arrivals, so big effort in the build up to Christmas, hoovering them out, or hydro excavation, and then just filling up flowable fill around them. Obviously building up to a Christmas shutdown when we could have a prolonged period of time where we could cut through under the bridge and basically build a new road pavement. So that was our first Christmas on the job. Really key that we met that milestone. I think we finished that flowable fill the week leading up to it, and then got straight into this. So that was done over this Christmas of 2018. Then with the bridge demo, so yeah, reasonably straightforward. Mill the asphalt off, find the old deck, and then lift out pieces by pieces. So we saw cut longitudinally down the each beam to cut the transverse tensioning, and then cut along the abutments at either end to cut the linkage bars, and then plucked beams out one by one. And then built the new bridge in as much real estate as we could afford. Deck pours. Just going to talk roughly about the stitches. So this is one of our deck pours. Can't remember which one, 4 or 5, I think. So getting ready for a pour, we always left to the right-hand side of those guys. We left that bit of concrete out, so that's where the reinforcement bars are protruding out of the deck we've already poured, and lapping with the ones in this current pour. So that's where the lap zone is. So we had to just be mindful of vibration when we stitch those two together. So that same precedence has been done a lot around the Auckland network. So we use the Smart Rock technology. A lot of people have probably used it, but it measures real-time concrete and concrete maturity, so temperature and time. Do a whole lot of testing before with all these cylinders, and it pretty much gives you a temperature time graph for the mix you're using. And then you get an app on your phone. This is a screenshots in Fahrenheit, but it gives you you just walk up there with your phone and it tells you how long the concrete's been there for, the temperature, and then its estimated strength, which is really important when you've got traffic lanes and Star Highway 1 closed, and it's coming early to Monday morning. You're watching your phone. We're also crushing cylinders as well as a backup, but the correlation was really good. It was good fun. Another photo there, just of the example of some of the small sections we could build. Like sometimes there was just no room to build anymore. We could get 2 Super Ts on one stage, and that was it. But every little bit of real estate was precious, so we could switch traffic. And then near the end of the project, we now needed to widen under Rosedale Road, the full width of Rosedale Road. So this again coincided with COVID level 3. I think we sort of lobbied, or the council may have lobbied us, just if there was any sort of work in construction that you could make the most of COVID. So even though we were not programmed to do this till the whole bridge was finished, we had the piles in, so it was we could actually remove the existing MSC walls. So we did work with the council, and we got approval to have another super weekend, which we just came in here and smashed the existing MSC walls down, and then got to a position where we could just complete the rest of the excavation on the day shift, just sort of a bit of a teaspoon method, but less disrupting to the public. And then dug right back to expose the piles. And then same again as Bridge 8, no headroom. Ideally you'd place panels like this prior to put the beams on, but we couldn't do that. So again, it was the modified excavator. This is only a 30-ton machine, the other one was 80. But again, the same sort of clearances. This one had temporary brackets on the top, so it was reasonably skillful operator just to get them in and work around the Super Ts and get them into position, but it worked really well for us. And that's all. Fortunately, I can't give you a finished photo of Rosedale Bridge replacement because it still looks pretty temporary under there with that future proofing for the bus station. And then in terms of other challenges, could talk all day, but I just picked a couple reasonably at random. But so this is Bridge 10, which we needed to widen. So Bridge 10 originally it was built in the mid-90s. The abutments were built wide enough, which was quite good, but we just had to cut the headstock off and extend the central pier. So we had to come up with a way to do that. The traffic lanes under Bridge 10 are extremely narrow, so our traffic manager at the time said you're going to have to design something that hangs from the sky. So we did our best. So we call this the diving board, but it was essentially 2 530 universal beams, just hung by 2 RB16 bars. And then, so obviously, they're in tension and the left-hand side's in compression working up against the bracket. So we erected that at night shift, scaffolded out, and then we worked up in there, scabbling back the old one and drilling the bars in and doing the Rio, all while the traffic sort of zooming in under our walkway platform there. And then, NCI for me was just the sheer quantity of volume of stuff we went through. So there's a bit of a beam count there, but 281 Super T beams over 3 years was like an impressive amount of, I guess, product to get through. I think in 2019, we did about 102 beams, and then 2020, the year of COVID, 152 beams. Like just the logistics and the planning behind that is, is intense. They're big units to manhandle, and also the production and the supply, and to meet your program, and a lot of coordination and organisation. So just a few photos there of some of the lifts, which became commonplace, but a lot goes into them. A lot of in the urban environment, a lot of traffic lights and street lights, and even the structures you're building, you wedge yourself in. There's just a heck of a lot of planning and logistics, including a few rogue street lights. I guess one of the luxury of a big job, these big viaducts were great, so we could place the beams. Obviously, we can't pour the integral ends until the beams are cured by 120 days. Some of that shrinkage has gone away. So with bridge construction, a lot of the work in a deck is in the reinforcement of the formwork. So at least if we could get the beams up there, it just unlocks heaps of work for our labour force, and we could go through entire decks and do formworks. We could pour the mid spans, but you can see in this photo there's quite a few ends that are not poured, but we're just waiting for that. Those 120 days from when the beams are cast, and we can pour the diaphragms, but we can do all the other work, which is where the manpower is. Don't know how much time we got, but just a little bit about, I guess, placing beams with cranes. I love it, but anyway, it might be boring. But yeah, a lot goes into it. I guess the simple thing is what you're lifting, how heavy it is, and where you can put your crane. Often, the biggest constraint is actually where you can fit the crane, and that pushes you back further, which means you need a bigger crane. Where the boom's going to be, and the clearances, and the track pressures, the outrigger pressures, and then most of our beams were placed at night, and we get the closure in at 8, 9 o'clock, and we've got to be off at 4. So a lot of time pressure. So yeah, the guys do a run sheet every night. On the right hand side there's a typical run sheet for a shift, and need to decide when the last call is going to be made that we cancel. We don't want to end up on the front page of the Herald. So yeah, it's all there. The last beam must leave the precaster at 1:15. So that's sort of like, I guess, the pressure that the site engineers are under. They need to be making that call that they cancel the shift about 1 in the morning, even though they don't need to be off technical 5 o'clock. So just takes a lot of time to set these cranes up, about an hour and a half to set them up, and hour to pull them apart. So you can't get off the motorway fast when things start going wrong. That might be the last photo, I think. Yeah, that's the project at the end. And that's people.
Thanks, Jonathan. We are slightly over time, I think. But what I'd like to do is to just show you a very quick video of the project, if you bear with me. It's only a 5-minute video, but I think it's quite it's well worth watching. I'll just bring that up.
Sorry, just so Paul, I think it's this video we put together. We had an end of project function in June last year, and just for the team to celebrate, we had a lot of video from throughout the project. It had been so especially for the video, it was just basically all these different throughout and came together.
We've had that problem before.
Is this on NZTA's website?
No.
Yeah, those are we might be able to edit it before it goes on YouTube to splice this in properly if we're allowed to share it.
Solve this.
You benefit.
Special treat for the in-person crowd, John.
Yeah.
Sorry, if you want to see the video, you got to show.
Did have this problem before, and you know how we solved it? Did have this problem before. I don't know how we solved
We're on Teams at the time, isn't it?
it. Yeah.
We can watch it without sound.
Oh, you kind of need the sound.
Let's be a live commentary. How about that?
Adam didn't see the video.
You play the music and I'll
Play the unsing track.
I'm not sure whether it's anything new. John. Maybe we'll have to.
For time's sake, we'll just try it without sound.
I think
Is it
Paul,
worth watching?
if you stop sharing your screen, it may give a different option. Streams call.
Thanks. Okay. With that, I'll invite any.
A little, one question.
Yep.
When you know how you're saying that the site concrete, when you dug under the underpass, that was to help let it fall down. How did you make sure that it didn't hit anybody? Or like, how did you do that safely as you're excavating there? Is it?
Oh, just the excavator could do
Could
it.
just
So
do it,
there was
nobody
no
would-
machine or person in there. They're just out in front of them, just pushing big slabs down.
Yeah, I got a question. The State Highway 1 to State Highway 18 underpass, it's obviously quite a novel structure and you came across a few challenges maybe you hadn't expected when you set out knowing what you know now. Would you do it again? Is it, you know, compared to the option of a bridge? Obviously it had advantages over a bridge, but in hindsight, do you think those advantages
I
you
think-
would opt to do the same thing again?
Yeah, I think a bridge is definitely be cheaper and quicker and easier, but I think the way the hybrid alliance works and providing, you know, the best value, I think that underpass probably almost won us the job.
Yeah.
So in terms of, yeah, I guess so. Yeah, to answer your question, yeah, bridge would have probably been easier, but I think the underpass won us the job and it sort of made the job. So yeah, I think we constructed it in the best way. I don't think if we're going to go with underpass, I don't think there's another structural form like. Sure, if we had a permanent case of the piles, it would have been easier, but the expense would have thrown up as well. So there's so many piles. But
Just the visual aspects as well, like everything just fits into the landscape there now, that being underneath. If you'd had another structure over the top, and then they're talking about in the future, if they got another one flying over the top of that, it would have been a bit of a spaghetti junction there with bridges all over the show. So it just fits really nicely and is.
Yeah, we may all like looking at bridges, but probably not everyone does.
yeah,
Yeah, and that was a key thing though, to the viaduct structure. There were constraints in terms of the span lengths as well, the skew that is coming over the existing State Highway 1, and even to longer spans and, thicker deck construction depth, and it was just pushing the viaduct quite up and, quite visually intrusive. So that's when we started looking at the underpass and came up with that solution.
The design team had to work pretty hard to make it all work. So the original concept design was to have the flyer over the top, but to actually make all the levels work with the falls, drainage, curvatures, fitting in with the existing landscape. There was a lot of work went into that, and it was a bit touch and go as to whether it was actually even going to work. But as the team did a great job to the geometrics and just the whole team, everything put to work.
The moisture issue that you discovered when you were doing the underpass. So the impression was that you weren't expecting that much moisture there.
and it's located right next to the water treatment plant, so the settling pond and whatever. Would you have changed anything that you'd done in terms of materials you'd used to do that underpass? Wondering what's happening behind those panels where you got the moisture behind the panels. Would you have used other materials at all or not?
Well, it was actually the material that we're excavating out of the underpass. The issue was the
Yeah, the moisture,
high
I guess
moisture
it's
content.
a fill through there, and that's all, you know, I guess it was with the water percolating out as we dug through, there was just this that natural drainage. So it was more the material we're excavating out, like we dig it out one evening and the next morning we come back and it's all soft. So it was just,
Right.
it was a product of the material we're taking out.
Yeah. But now you're taking it out and behind those panels, there must be the space between the piles and whatever. Is there any potential for whatever's back there is going to have an impact on those panels? Like, would you have changed what you used?
Drainage, there's basically a drainage system, so the weep holes come down, drop into a drainage system and then gets taken away. So it's, it was, as I guess as we excavated it out, it was just, there was a lot of water around and we're having to run temporary drains to keep it all flowing in a way. But yeah, over time that sort of tapered off a bit. And particularly for getting the road through there, we probably spent a bit of money on putting some extra lime and cement into the subgrade there to give us a bit more resilience as we're building it, and getting our subsoil drains. We've got to put a lot of extra subsoil drains through the subgrade to make sure it was well drained, and we're going to have punching up issues later on.
I'm just going to say some of those pictures look actually quite familiar because I used to drive that road for a long time, you know, going up north and south, back and forward. And I was just thinking, I mean, I was just having a read earlier actually with regards to the new potential second harbour crossing. And obviously, you know, I believe it's in the public consultation phase at the moment, but the estimated cost for that project looks like it's going to be more than $50 billion. That's what I've just read. So I guess what's the difference between designing a sea bridge, you know, if the harbour crossing project goes ahead, which it may not, and the difference between a road bridge? Are there many more challenges designing a sea bridge with underwater tunnels compared to a road bridge? Sorry.
Yeah, sorry. I mean, the key challenge on this project was building stuff in and around the existing traffic. If you're putting, you know, if you're doing a second harbour crossing, you wouldn't necessarily have that. You know, if you're building, whether it's a bridge or a tunnel, you know, you'd be building something that's offline from what's there at the moment. There's many different challenges with putting a harbour crossing over. You've got to think about foundations in water, potentially deep water. And you know, you're also looking at if it's a bridge, you're looking at, you know, potentially longer span structures, much bigger structures, you know, significantly bigger structures. You know, navigation clearance, like, you know, as per the existing harbour bridge as well. But all those things, you know, like basically larger scale than the structures that we've got on this project. This project had different challenges. It was all about building stuff in and around a very busy motorway section, catering for the traffic, catering for the travelling public. You know, things are relatively smaller scale compared to a harbour bridge type project, but you know, nonetheless, it's a very, very challenging project from that perspective.
With the Rosedale Bridge, obviously constructed in, was it 6 stages? 5 was it? Right.
6.
Yeah.
We lost track.
So yeah.
Yeah. Did you have any issues with, I guess, any like differential hog between the various, you know, it looked like you were placing
New build.
Yeah, and the new build?
I've come across that before. I don't think we had it too bad there.
And was there anything, I guess, in the specifications around like casting all good at the same time or certain period before planned casting?
Not at the same time, it wasn't. 120 days for.
We had 120 day age limit on that, didn't we, with the beams. I can't recall there being a significant issue with differential hog on Rosedale. The Bridgetown Constellation bridge winding, which was sort of more conventional winding, where we're putting new construction on the edge of the existing. I think there was an issue there, if I remember rightly, with the new beams coming up slightly higher. And I think there was a little bit of amendment of the design that needed to be done in terms of the deck slab and the deck slab stitching into the existing for that. And that was just, you know, it's very difficult, isn't it,
That's right,
to
yeah.
predict on beams, and whatever you predict, it's something different. We found that we found that the beams were I think slightly higher. The new beams were slightly higher, and we had to do a little bit of doctoring on the connection reinforcement into the existing deck. But I can't recall it being an issue on the roads.
The viaducts, it looked like they had quite variable span length. Was there quite a big variance in span lengths on those? From the elevation, it looked like there may have been, but I was just wondering if that created any unexpected challenges or design wise. Maybe that's so far in the past now, but
Yeah, they may have done at the time.
yeah.
Not to my recollection, no. You're right. There was some variability in spans, obviously, depending on what the obstructions were at the ground level. I couldn't recall what the range would be. Maybe for some of those, you know, like Caribbean Drive viaducts, the long 250 metre long viaducts, it might vary perhaps something from 25 to 35 metres in span length, but I don't think there was a particular concern in terms of.
Yeah, okay. Just from the elevation, one looked quite short, but it only flashed up on the screen.
Which was 25 to 34.
Yeah. I can't recall it.
Yeah,
a particular issue in terms of a differential. One of the Albany busway bridge up at the northern end was quite challenging in terms of standing. We were using 1500 deep super T's on Albany busway bridge, but we managed to get a 38 metre. The central span is 38 metres on that, so it's really pushing it. I mean, the integral form, you can get a bit more out of it with the integral form, and we did change the construction sequence on that so that for most of the super T structures, once the beams were landed, we cast the deck span, the mid span part of the deck first, and then did the integral connection afterwards. We actually turned that round on Albany because of the long span, because we wanted to get that wanted to make it integral first, so that it reduced the sag on the main span. But no, other than that, it was fine. Any questions from anybody online? I can't see anything in the chat.
Thanks, Paul.
Okay.
Very informative.
If there's no other questions, then yeah, we'll call it there. Thanks very much for attending. It's really appreciated. Thanks to everybody online for joining us. Yeah, look out for the next Bridge Group meeting. Do we know when that's likely to be, John?
I guess in next quarter, 3 months, but Miss and the steering committee will figure out who's next. So applications, you know, send it in if you're keen. Got a project.
Okay, thanks.